Identify the half reactions and standard reduction potentials. From the provided information, write down the reduction half reactions and their associated standard reduction potentials. E degrees rad Ag to the power plus plus e to the power negative gives Ag quad E degrees rad equals plus 0.80 VZn to the power 2 plus plus 2 e to the power negative gives Zn quad E degrees rad equals minus 0.76 V. Determine which half reaction undergoes oxidation and which undergoes reduction. For a thermodynamically favorable reaction in a galvanic cell, the overall standard cell potential, E degrees cell, must be positive. The half reaction with the more positive reduction potential, Ag to the power plus, remains as a reduction at the cathode. Ag to the power plus plus e to the power negative gives Ag quad E degrees rad equals plus 0.80 V. The half reaction with the more negative reduction potential, Zn to the power 2 plus, must be reversed to represent oxidation at the anode. Zn gives Zn to the power 2 plus plus 2 e to the power negative quad E degrees ox equals plus 0.76 V. Reversing this oxidation half reaction yields a positive overall cell potential of E degrees cell equals plus 0.80 V minus 0.76 V equals plus 1.56 V. Balance the electrons transferred in the redox process. In any balanced chemical equation, charge and mass must be conserved, meaning the number of electrons lost in oxidation must equal the number of electrons gained in reduction. The zinc oxidation half reaction releases 2 electrons, 2 e to the power negative. The silver reduction half reaction accepts only 1 electron, 1 e to the power negative. Multiply the silver reduction half reaction by a factor of 2 to balance the electrons. 2 Ag to the power plus plus 2 e to the power negative gives 2 Ag. Combine the half reactions to generate the final net ionic equation. Add the balanced reduction half reaction and oxidation half reaction together. 2 Ag to the power plus plus Zn plus 2 e to the power negative gives 2 Ag plus N to the power 2 plus plus 2 e to the power negative. Cancel the 2 e to the power negative from both sides of the equation to arrive at the final balanced net ionic equation. 2 Ag to the power plus plus N gives 2 Ag plus N to the power 2, plus this matches option D. The correct answer is option D. 2 Ag to the power plus Zn gives 2 Ag plus Zn to the power 2 plus.